Tunnels construction has evolved in recent times, thanks to the application of revolutionary excavation methods, which allow the construction of advanced and complex infrastructures in a more effective and safer manner. This has led to the development and consolidation of mechanized excavation with tunneling machines. The pressure shield tunneling is one of the most safe and profitable methods of tunneling. Each segment for a tunnel is built in an assembly line close to the storage area. It starts with the welding of the metal formwork that conforms the segment core and shapes it. In a cage mold, each formwork is forged with concrete and is baked under specific foundry conditions. Throughout the process, the workpiece is subjected to constant eye exams to ensure its shape and quality. The segment has different hollows and turnings to assemble different rubber pieces to it. These pieces are glued to the concrete in this phase. At this stage, each segment is marked using different painting techniques with its ID and all the necessary information. The segment leaves the building area and it is transported to the storage area. A crane takes each piece in a specific place outside the building area and moves them to the specific storage point. Note that each segment is placed in a specific order in the appropriate ring. The whole storage area is packed with rings, some to be used in the tunnel and others in different storage or maintenance areas. The train moves the segments ring by ring to the train to finally use them inside the tunnel. The different sensors and devices implemented in the context of eSONIA will be deployed in the tunnel, and the information they provide will be interchanged via Wi-Fi IP6 technology. This information will be stored via web services and will be processed in the cloud using the KPI format. These KPIs in different scenarios will be used both at real time or when required for accident prevention due to the close proximity of operators and cranes. Accident prevention due to operators' flow toward restricted areas. Accident prevention due to the identification of areas with low luminosity. Improvements on the quality of materials as well as the predictive maintenance related to humidity and the adherence of the rubber pieces in the segments. Segment location, identification, transport and management within the storage area, improvement and optimization. Various elements are deployed in this scenario. Humidity sensors close to the segments and distributed by the storage area. Luminosity sensors integrated into the previous sensors or in an independent way. GPS integrated in different devices or standalone mounted in the machines. RFID tags and readers. Web services developed to connect different applications and devices. Applications in the mobile devices for the different operators. Structures in the cloud, application servers, web services, and storage. All these elements will feed and process the luminosity, humidity, and location KPIs of interest in the current use case. After the deployment of the different elements that conform the proposed eSONIA solutions, the segments will go from being identified using a manual or visual way to having RFID tags that can be read by an operator or by the cranes. The luminosity sensors will at the same time allow the identification of non-illuminated zones, being able to create in real-time alert zones to advise the operators about the low visibility at those zones. The humidity sensors will allow the performance of a historical track of that parameter. This will enable us to know which items in the storage area have deeply suffered this issue and need an intensive and detailed revision. At the same time, the GPS sensors provide information about its location to each item, allowing the automated management of the storage that will optimize it using diverse location algorithms. This allows the remote control, even the fully automated control, of the cranes without needing an operator personally moving close to each piece to ensure its correct placement. Those same GPS sensors will help to avoid possible collision problems between the crane and the operators, or even that the operators would move around non-allowed zones. This information will be transmitted to the operators using different devices. The tablets and the data capturing devices will be the most common in the demonstrator. As a whole, the management, location, movement and maintenance of the segments and rings will be significantly optimized. At the same time, the working security parameters of the operators will be dramatically increased.